What is zone melting is about? Zone melting is any of a group of techniques used to purify an element or compound or control its composition by melting a short region and causing this liquid zone to travel slowly through a relatively long ingot or charge of the solid. Zone melting is a means of using the freezing process to manipulate impurities. It combines the fact that a freezing crystal differs in composition from the liquid from which is crystallized with the idea of passing a short liquid zone along a lengthy solid.
The zone melting is one of the methods that have been used to study the behavior of impurities in aluminium. The method of synthesis of the behavior of impurities in zone melting of aluminium from the study conducted by Duan et al. At 2022, the sample used was the raw cuboid aluminium sample with uniform impurity content. The sample surface was polished in a mixed solution of ethanol and hydrochloric acid to avoid contamination from the material surface during experiment. Then, the sample is rinsed with ethanol before placed in a graphite boot. The same graphite boot was placed in a closed tube and then a protective gas was introduced to prevent oxidation of the crucible and aluminium sample, which the gas used is argon gas. Because the graphite had magnetic conductivity, it was heated by a magnetic induction coil and then the heat was transferred to aluminium to realize the melting and flow of the aluminium. In the experiments, the travel speeds of the molten area were 1.5 mm per minute and 1.0 mm per minute. The temperature was controlled at 660 degrees Celsius to 680 degrees Celsius, and number of zones melting times were 5, 10, 15, and 20 respectively.
Next, characterization of the compound. We can analyze the sample by using GDMS and SEM. First, we can analyze effects of the melting times on impurity using GDMS. Figure 1 and 2 show the impurity change of zone melting at 1.5 and 1.0 mm per minute travel speed. At travel speed 1.5 mm per minute, the aluminium content in the same position of the product increases with an increase in the number of zone melting times. At travel speed 1.0 mm per minute, the purity of aluminium is greatly reduced in the tail after the impurity accumulates and is not up to the national standard. In this context, the tail should be removed to reduce the cost. From comparing the GDMS results of the two groups of experiment, it is found that with the same number of zone melting times, the contents of the impurity copper, silicon and ferrum decrease in the head end of the aluminium sample, while titanium increases in the tail of the sample. Next, the crystal morphology characteristic using SEM. Figure shows the microstructure of aluminium sample. During the solidification of the aluminium melt, the crystal grains change. The movement trends of the different impurity elements could be inferred from the changes in the particles. From the SEM image of the raw material, it can be seen that the surface of the raw material has an irregular structure and is layered over, indicating that the crystals of unmelted primary aluminium in different parts are irregular particles. Figure 8-2D shows that the crystal size is small at the head and tail end. It is because different impurities affecting the growth of crystal.